Good morning, teachers and learners. My name is MJ Siapamore from FS-IBP District. Today we are going to discuss what has been a thorny subject to the subject physical science. I think learners, either learners or teachers, there is somebody who's failing this concept that I'm going to deal with. We are going to deal with answering the multiple choice questions. So other people, they take it very for granted, but it costs a lot of marks for your liking. So right away, I'm going to make a presentation. We can look into the presentation. I've named it answering the multiple choice. We can go straight to presentation and then we are ready to start. Can I continue with presentation? Yes. So the first slide, it talks about answering the multiple choice questions. So what are the things that we really need to look into that? Multiple choice question, it constitutes about 13% of 150 marks, which is very, very important marks. You must remember, learners, for them to pass with level 2, they need only 30%. So in an event where learners, they can get all the multiple choice questions, will be standing in a better position to achieve even more than 30%. It is 20 marks for 150 paper. That is at stake here. So let me start by looking into the analysis of 2020 December paper. So this is paper 1. And we had some challenges in other topics here. We can look into the question 2, where learners, they obtain only about 28%. This is only multiple choice in multiple choice, and it was about around Newton laws. And then 1.4, which is about vertical projectile motion, 28%. But the worst performed question, it was question 1.5. Which is a multiple choice question on work, energy, and power. And then question 1.8, which is electrodynamics. So this is the picture that we would like to ensure that we improve. We have to make means to make sure that we change this picture. In paper 2, this is the scenario, question 1.2, organic nomenclature. It was troublesome. Generally, this picture can be improved. 1.6, which is application of Lacatiel's principles, it can also be improved. So we need to try with this 2 hours just to make sure that we are going to improve this. So this is what is important when answering the multiple choice questions. Number 1, we have to read the question thoroughly. Before you answer the question, make sure that you understand. I'll explain this in a second. And read every answer option that is given. Pay attention to key or bolded words in a question. And then this one, the fourth, it will be know your definitions and principles, because some of the questions, they will be around the principles and definitions, and then use the process of elimination. I'll explain in a few minutes, in a few seconds. And then the scale down the calculations of ratio, because sometimes they ask you the question, especially around Newton universal gravitational. They always ask around the ratio, what happens if the mass is doubled and all the stuff. So I'll explain what do I mean by saying you should scale it down, the calculation. Answer it in your mind, and then lastly, you must make an educated guess. I said this deliberately because most people, I see learners not answering a multiple choice. They leave some options not answered. You must take a chance, because when you are leaving the blank space without answering, you are not taking any chance. So you must take a chance, make an educated guess if it takes that. So what do we mean by read question thoroughly? you must read through both question and the answer more than at least once, maybe at least two times. You must make sure that you read with understanding. I think people in the past, they used to complain about the language in physical science, but it's getting better and better because we can see that teachers are making an effort to make sure that learners, they practice with question papers so that they get used to the language in physical science. And then you must not be taken by excitement. Sometimes other people, they read at a glance, and then once they read at a glance, they think the answer. You must remember some of the answers are there to confuse you. So once you read at the glance of the question without understanding and be taken by excitement, there are chances that you can get it wrong. So double check your answers. That is very important. So they eliminate distraction. So all multiple choice questions, they have distractors. The next slide, I'll be talking about that. So how do you eliminate these distractors? Some answers are obviously wrong in a multiple choice, so which are called the distractors. So you can eliminate. When you have studied well, it is easy for you to identify the distractors. Eliminate answers to at least two answers. So the multiple choice, in most cases, when you are able to eliminate distractors, you'll be left with only two questions, which will be the one distractor and the correct answer. So sometimes the answers may be looking very, very similar, but there must be the most correct answer of the two. So you must come to that conclusion that this one is the most correct answer. So let's look what multiple choice entails. A multiple choice entails the following. It has a stem. That's where your question is. That's what you need to answer. And then there are options. And there are four options and one answer which is correct in those options. And then about three distractors. So in this case, you have to know the difference between the vectors and the scalars and just easily identify which one is a vector and answer that question in easy 2 marks. So scaling down the numbers. I'll take an example. I think I have a question that we can tap into explaining exactly what do I mean by scaling down when substituting in the formula. When question is about effect of ratio or the relationship of variables on each other, like for example, if mass is doubled, what will be the effect on the force? When mass is doubled or distance is halved, what will be the effect on the force? So you can do a small calculations with scaled down numbers. Scaling down numbers, I mean you can use as small as possible numbers to substitute and to ensure that you are able to see the effect of the change in those variables to the question, the variable in question. Use as small as possible numbers to prove the relation. It will be easy for you to come to the correct answer. So I took some few of my first slide, of this slide actually. I only explained a couple of them, but I think we are ready to go after doing that. So we are going to take a lot of examples. I think I've got almost 40 questions of multiple choice, and then we are going to look into them as to how best can we ensure that we collect the marks as much as possible. Which one of the following, it is just one of the example earlier, which one of the following quantities represent a vector? So when approaching this question, the learner must know what is the difference between the scalar quantities and the vector. So in this case, this one is quite simpler. C will be the vector because C has magnitude and direction, which is one of the difference between the scalar and vectors. So looking into the question number 2, consider the following momentum versus time graph for a moving object. Some part of the statement, they will just lead you to the correct answer. For example, let's read the second part. It says, which one of the following expressions represent the net force of the object for the 20 to 30 seconds, between 20 and 30 seconds interval. Assume that the momentum is conserved. So it tells you the final velocity, the final time here may be 30 seconds. So you can just go through the answers there, just go through the answers. And here I see something similar to the instruction. The instruction talks about 30 and 20 seconds. And in one of the options, there's 20 and 30 and 30 seconds, whereby we know when we calculate the net force, we are looking for change in time, and change in time in this case is 30 minus 20 seconds, and others they are 30 minus 10, 10 minus 0, 10 minus 0 there. I don't think they are helping, because scenario there and scenario there on top, they are almost the same. So they also direct you in the direction towards what is indicated as time intervals there. So let's check the correct answer. So C definitely is the correct answer. That is where you might be able to take an educated guess in case like this, whereby you are not able to probably work it out or come up with the necessarily solution that is worked out. But some of you remember the slide where we talk about the bolded information and stuff like that. They give you some direction as far as this is concerned. So in this case, C is the correct answer to represent the net force. And then let's look at this one. So I would like us to work a little bit on this one, just to verify our answer there. It says the kinetic energy of a car moving at a constant velocity v is equals to k. The velocity of the car then changes to 2v. What is the new kinetic energy of that? So let's try to understand. So we know the equation for kinetic energy. It is equals to half mv squared. So we are interested in what is happening about that v. So it says the kinetic energy of the car moving at a constant velocity v is v, is equals to k. So when the velocity is v, kinetic energy is equals to k. And then the velocity changes to 2v. So when velocity changes to 2v, we are going to have a situation whereby we are going to have something like that. In fact, there I was supposed to write it outside like that, something like that. So on that lens, looking just on this, you are able to see you're going to have a 4v squared there. So it means the ratio of kinetic energy is going to be affected by the factor of 4, since we have used that, if you understand what I'm saying. For example, let's say a mass in this case is 1, and then when we substitute mass as a 1 there, all over this, and then we are going to have 4 equals to 4k like that. So going back to that, we can just check. The answers are A, half quarter k, and half k, and 2k, and then 4k. I suspect it should be the 4k, because at least I've managed to do a little bit of a calculation just to check if I'm going in the rightful direction. And then the next one, a car is moving at a constant speed. Which one of the following statements about the car, about the force acting on the car, is correct? So I'm going to read through the answers like I mentioned in one of the slides up there. It says the net force acting on the car is equals to 0. So the key word here is moving at a constant speed. Moving at a constant speed. So number B, it says there are no forces acting on the car. it is not possible that the car can move if there are no forces acting. So we can eliminate number B, and then the weight of the car is equals to the normal force acting on the car. So let's say for argument's sake, we accept this one for now. We eliminated B, and then number D, there is non-zero force acting on the car. In fact, we can eliminate C because it talks about the vertical forces that are cancelling each other there. And the car is moving on the horizontal, so we have to check into the effect of the horizontal forces, whether in the direction or in the opposite motion of the opposing the motion, I mean. So number D, it says there is a non-zero net force acting on the car. So number D, if there is a non-zero net force acting on the car, one of the two things should be happening. Number one, the car should be accelerating in a positive direction, or the car should be decelerating if there is non-net force. There are unbalanced forces. It means there are non-unbalanced forces acting. There is one force that is greater than the other force. So the car should be moving in a certain direction, either accelerating or decelerating. So far, what makes sense to me is number A, the net force acting on the car is equals to 0. The forces are there, acting there, but the forces, they are cancelling out each other. So I suspect A should be the correct answer. So A is the most correct answer in this case. And then looking at this one, I think we have to work something there just to verify what is happening there. So a ball of mass m strikes a wall perpendicularly at a speed of v. Immediately after the collision, the ball moves in the opposite direction. So we have to be very careful here. Once the ball changes direction, we must show the direction of velocity either with a positive or a negative. So at the same speed as shown in the diagram, which of the following represent the magnitude of the momentum of the ball? So let's look closely to this one. So we are having a ball moving towards the wall, and then the same ball is moving away from the wall. So we can take the velocity, it's moving with the same velocity. So what we can do here, we can take the velocity towards the wall as negative and away from the wall as positive. So when we are looking into this, we are looking into the change in momentum, which is equals to m into v final minus v initial. So in this case, this is our initial velocity, this is our final velocity. Then we will have m into v final minus this is the sign of the equation, and then minus again minus v. So what is going to happen there? Negative times negative is positive, so it means we are going to have 2v there. So we are going to have m into 2v, which is the same as 2mv. So this is the answer that I'm expecting from there. So let's check from our answers. Do we have 2mv? Yes. And then we did a little bit of proving there just to check if the answer is 2mv. So 2mv is the correct answer because the velocities, there are possibilities that people may get it wrong here if they don't realize that the change in direction there, it indicates, it must be indicated either with a negative on the final velocity or in the initial velocity. So that is the story about that question. We can move to the other question. An object moves in a straight line on a rough horizontal surface. If the net work done on the object is 0, then the object, number A, has a 0 kinetic energy. So what do we mean by object having a zero kinetic energy? Kinetic energy, one of the factors in kinetic energy is velocity. So you can imagine when velocity is zero, moves at a constant speed and moves at increasing speed on the rough surface, and then moves at a non-zero constant acceleration. An object moves in a straight line on a rough surface. Or the rough surface means there is a force that is acting in the opposite direction of the motion of that object, but the object persists the motion in its original direction. So the possible answer here, it must be the object must still continue to move. It cannot be number A, which is zero kinetic energy. Probably it moves at a constant speed. Number C, it moves at an increasing speed. Those are possible too, which is B and C. We can eliminate A and we can eliminate D. Because D says it moves at a non-zero constant acceleration. So let's check what is the correct answer. So the correct answer here, it will be B. It means the object is moving at a constant speed. That rough surface may be exerting a frictional force in the opposite direction of the motion, but the force that is from the object itself, that is applied on the object, it is such that it's able to cancel out the effect of the rough surface. That is why the object will continue to move at a constant speed. So let's check the next one. An object is traveling at a uniform acceleration and the direction of velocity and acceleration are the same. So reading just that, you are able to realize if the direction of velocity and acceleration are the same, this means the object is speeding up. If the direction of acceleration and velocity is the same, this suggests that the object is speeding up. This means that number one, A moves at increasing speed, B moves at a decreasing speed. We can eliminate that. We can eliminate that when direction of velocity and acceleration are the same direction, the object is decreasing the speed. That is not possible. And then number C moves at a constant speed. Maybe we can keep this one. And number D, we can eliminate the object is at rest. Because there's no way the object at rest can travel at uniform acceleration. So we are looking at the two options, which is A, moving at increasing speed, and then C moves at a constant speed. So which one is the most correct one? The most correct one is number A, because when velocity and acceleration are acting in the same direction, the object is speeding up. So speeding up in this case, they chose to write it as increasing the speed. So that is the most correct one in this case. And then one of the indicators up there, it says you must be clear about your definition and principles. So let's look at this one, because it gives me the impression that we are dealing with the definitions or something similar to that, or interpretation of the definition in this case. A ball is dropped onto the floor and bounce off the floor to the same height from which it was dropped. To the same height, which is very, very important. Which one of the following laws best explain why the ball experienced the upward force? So according to this statement, the magnitude of the force of the ball towards the ground is equals to the magnitude of the force of the ground on the wall, or on the ball. I mean, the ground, the force that is exerted by the ball on the ground is equals to the force that is exerted by the ground on the ball. That is why it goes to the same height. So that is action-reaction. If you understand what I'm saying, we are talking about action-reaction. And then Newton's first law, it does not talk to action-reaction. Newton's second law, it does not talk to reaction. But Newton's third law, it talks about action-reaction. So the possible answer here, it is number C, which is Newton's third law, action-reaction. So that is the correct answer. C will be our correct answer in this case. I think we are moving on nicely now. So this one, I think this one we can just continue to talk about that scaling down of numbers, just to explain what is happening. Two objects, each of mass m, are placed a distance d apart as shown below. The gravitational force of the one on the other is F. So what is important? The magnitude of the force increases to 4F. So let's work this one out a little bit. Let's work out this one a little bit. So we can see that it is Newton gravitation. So F is equals to K m1 and m2 over r squared. So scaling down, I can say K is equals to 1. I know K is a constant, and m is equals to 1. For the sake of getting to the correct answer, m2 is equals to 1, and then r is equals to 1. So when I substitute these values, it will be 1 multiplied by 1 multiplied by 1 over 1 squared. So it means r, your force is 1 in this case. But you must remember on the question, they said the magnitude of the force increased to 4F. So we want to check out of this. Let's check the first one. It says the mass of each object is increased to 4. So let's check what will happen if the mass is increased to 4. It means we will have a situation like K is 1, and then the first mass is 4. The second mass is 4. R is equals to, 1 squared in this case. So it means this side we are going to have a 16. So this one is incorrect because according to the question, they said the magnitude of the force increased to 4. So we must calculate such that we have 4 on the left-hand side. So let's take, you have seen what I've done with the first one. You can try them. Let's look at the last one, number D. Number D, the distance between the object is decreased to half. So the distance is halved. So if the distance is halved, this is another option. We will have K is 1 multiplied by the first mass is 1. You must remember we are not talking about this. The original is this one. The original is where mass 1 is 1 according to that information, and mass 2 is also 1. So it means we keep the top one as it is. And what we are going to do this time around, what we are going to do, we are going to halve the distance. So you must remember half of 1 is half. That is why I'm keeping it like that. So the next part, what is going to happen here, we are going to have 1 multiplied by 1 multiplied by 1. And then on top of that, we are going to have 1 over 2 squared, which is 1 over 4. So we know if it means we are dividing this by 1 over 4, but we can change this to multiplication. We change this to multiplication, and the reciprocal of that, it will be 4 over 1. So we cancel this one out. So 4 multiplied by 1 multiplied by 1 multiplied by 1 is equals to 4. So it means it is possible that this answer can give you the ratio, the factor of on force to be 4 like it is on the question. So the magnitude of the force increases to 4F. When it means the correct answer should be D. When the distance is halved, the object decreases to half D. with the mass constant. The mass is constant, mass remains 1 according to our calculation, but the distance is halved. So when the distance is halved, that's where we are going to have the only time we are going to have the effect of 4 multiplied by 4 or increased to 4. It is when the distance is halved. So then this is what I meant when I said we must scale down the calculation to the as small as possible numbers that we can use just to get to the correct answer for the sake of multiple choice. But you cannot do that on structural questions. Which one of the following velocity time graph best represent the motion of the ball if the upward motion was taken as positive? So it means in this case, your answer, one of the graph that represent that, because it's velocity time graph, we are looking at the straight line graph, and then in this case, the motion upward motion was taken as positive. It means we are going to look into the velocity that projects the object upwards as a non-zero velocity. It cannot start and move upward with a zero velocity. So the velocity must be greater than 1. So which one of the following? A and C, the velocity is greater than 1. And then even this one, it has a velocity, but this is a negative velocity according to what we used to look into these graphs. So the most possible answer, it should be A in this case. This will be the upward motion with the positive velocity, and then this one. And then at this point, the velocity, the object reached the maximum height at 0. We know when the object moves vertically upward, it reached the maximum height at 0, and then it changed the direction, moving downwards in this case. So I think number A should be the correct one. And then the next one, the frictional force acting on the sliding object. Number 1 is inversely proportional to the normal force. Number 2 depends on the magnitude of the area of contact. Number 3 depends on the motion, the velocity of the motion. And then number 4 on the type of the surface. So frictional force, inversely proportional to the normal force, I think that one is obviously not relating with what we are talking about. Normal force is acting perpendicular to the surface. So we cannot entertain number A. We can just eliminate number A. Depends on the magnitude of the area of contact. We can look into that. Depends on the velocity of the motion. We can probably just check into that as well, and depends on the type of the surface. But the frictional force, in most cases, it depends on the surface, the type of the surface. Because when we say the area of the contact, we are just talking about how long is the object in contact with the area, but we are not talking specifically what type of the surface is that. So the answer will be D. The type of the surface, it determines the type of the frictional force that is acting that. If the surface is smooth, we may have as small as possible frictional force. If the surface is rough, that is the type, not the magnitude, not the area, the type of the surface. The frictional force acting on the object depends on the type of the surface. And then we can look into this one. A non-consecutive force is a force. So in this one it comes from the first part that I was talking about, the definition. A non-consecutive force can be defined as. So if you know your story about the definition, you'll know that the non-consecutive force is a force for which the work done in moving an object between 2 points depends on the path taken. So when looking into the answers, I see the number C as the most correct answer according to the definition. So we can move to the next one. An object is projected vertically upwards. Ignore the air resistance. As object rises, what happens to the velocity? We can entertain this. Let's say we are having an object, our ball in this case, that is projected upwards. What we know about the object is that at the top of that motion, the velocity, the final velocity for the upward motion is equals to 0. So it means the object starts from a non-zero value of velocity. So it means velocity here, it must be greater than 0. But as the object moves upward, the velocity of the object is moving towards 0. It's moving towards 0. So what does it mean? It means the velocity as the object goes upward, the velocity decreases on that path of the upward motion. So let's go to the question again. An object is projected vertically upward. Ignore the air resistance. As the object rises, the velocity, number one, it says, so here, when looking at the answers, they are comparing the velocity and the acceleration. So let's eliminate. Number one, we said we agreed from what I drawn there that the velocity decreases. And it is only A and C that talks about velocity decreasing. So these ones that talks about velocity increasing, when the object is projected vertically upward, we eliminate B and D. So we are left with only A and C. So A decreases and its acceleration remains constant. And then we know acceleration for vertical motion, in most cases, we know it is 9.8. So if it has that value that is constant, it means it has a constant value for the vertical projections. And number C, decreases as its acceleration increases. So acceleration remains 9.8 throughout. Even when we calculate for vertical projectile motion, we calculate the acceleration as 9.8, meaning it is constant. So the most correct answer here, it is decreases, the velocity decreases when the object is projected vertically upward, and the acceleration remains constant. So A should be the correct answer for this case. So we will be taking a break in a few minutes. Before we take the break, let's just entertain these two questions and 2 or 3 questions. This one, it says PQR are 3 spheres. The spheres PQR, when P and Q are brought to each other, they experience attractive force. But when Q and R are brought near each other, they experience the repulsive force. Which statement is true about the charges? So let's check it. Let's entertain this one as well. Let me quickly get it. Let me get it here, what they are actually saying here. So we have P, sphere P, and then a sphere Q. So this one, when they are brought close to each other, they attract each other. They move towards each other. So what does this say? It says they are oppositely charged. P and Q are oppositely charged. And then we have the third sphere, which is R in this case. Let me put that R and the sphere there. So when now Q and R are brought to close to each other, they repel each other. So P and Q, they are oppositely charged. And then Q and R, they they are alike. They are charged. They have the same charge. Q and R. What I can see from this is Q and R. They are carrying the same charge because they are able to repel each other. So which statement is true about this? Number one statement, let's go back to that. Number one statement, it says P and R have charges with the same sign. So what did we say about P and R? P and R, let's check. Let's go back here. So they say P and R, they are carrying the same sign. But you must remember, R and Q, they are carrying the same sign. So if R and Q, they are carrying the same sign, and P and Q, they are not carrying the same sign, there is no way P and R are carrying the same sign. So we are eliminating number one. So there's no way P and R they have the charge with the same sign, because Q is similar to R and Q is not similar to P. Number B, it says P and R, they have the charge with opposite sign. P and R, it means P and R, they should attract each other. The second answer, it says P and R, they should attract each other. If Q and R, they have the same charge because they repel each other. If Q is attracted to P, then R must also be attracted to P. So it looks like B, but let's entertain the other one. It looks like B is the correct one. So let's look at C. C, it says PQR have charges with the same sign. There's no way P, Q, and R, they can have the same sign, because Q and P, they attract each other. At least Q and R should have the same sign, but not P. And then number D, P, Q, and R have equal charges. No, it's not about the magnitude of the charges. It's not about that. We can eliminate that. So to me, B remains the correct one, because if P can attract Q and Q can repel R, it means P can also attract Q. So that is why P and R, they have charges with opposite sign. So this one, this is a background knowledge that you must also remember again. Let's look at this. Consider the electric field pattern around the charged sphere, Q, R, and S. So what do we know about the electric field lines? When they are out of the sphere, it means that sphere is positively charged. So in this case, Q, the arrows are moving out of the sphere, it means Q is positively charged. R, the arrows are moving out of the sphere, it means R is positively charged. S, the arrows are moving into the sphere, it means S is negatively charged. So what conclusion can we make now is at least Q and R are positively charged. So it means we can eliminate A, that says Q is negative. We can eliminate C, that says Q is negative. But at least when they say Q and R are positive, we can entertain that. So it means we can entertain C and D in this case. C and D. But what is wrong with D? D says Q is positive, R is positive, and S is positive. But the arrows in S, they are coming in to indicate that S is negative in this case. So it means the most correct answer here, it is B. Q is positive, R is positive, and then S is negative. And in this case, the sketch below shows two small metal spheres, A, B, C, on the insulated stand. They carry the charge of magnitude Q and 2Q, respectively. the distance between the centers of the sphere is R. Sphere exert the force with the magnitude of F on sphere B. What is the magnitude of the action-reaction? So the answer here should be simple to identify. Action-reaction, which in this case F, the same amount of force will be exerted by a different sphere to another sphere. So maybe the last two slides, and then we will look into this. So two bulbs X and Y are connected in series. X and Y, they are connected in series. I'll show you what I'm drawing now. I just want to make it snappy so that when we solve it, we know exactly what we are doing. So the two bulbs X and Y are connected in series to a battery, and then bulb X is brighter than Y. So once they say bulb X glows brighter than Y, the impression that I have while they are in series is that bulb X has the higher resistance compared to Y. Ignore the internal resistance of the battery as well as the resistance of the connecting wires. So X and Y are then connected, are disconnected and reconnected in parallel with each other to the same battery. Which of the following combination is correct? So let's entertain this just a little bit. Let me put it rather than this. So we have the X and Y. So this one is brighter. This one is brighter than that one. So I said the impression that I have is X is having high resistance. So now they are connecting them in parallel. When they connect them in parallel, the current is going to divide. If this has a high resistance, less current will be flowing through the X, and more current will be going to the Y bulb in this case. If the impression that I have is the correct impression. So, but let's listen to the question. What does the question really say? The question says, number A, comparison. But before we look into that, normally the parallel connection, they will always give you the brighter reaction to bulbs. The parallel connection will always give you the brighter the brighter of bulbs, brightness in bulbs. So look at this comparison of the brightness of X in series versus a parallel connection. So what I'm saying is parallel connections, they will always give you a better brightness. So in this case, it means if brightness is related with a series connection, I'm going to eliminate that. I'm going to eliminate B, and I'm also going to eliminate D, because brightness is related to series. But under general, the brightness is related with parallel connection. So I eliminate A and I eliminate C for the first part. That says comparison of the brightness of X in series versus parallel connection. So X will be brighter in the parallel connection. Yes. And then on the right hand side, comparison of the brightness of X and Y in the parallel connection. So you must remember, in the parallel connection, I said current is going to divide there. And as current divides, X has high resistance. More current is going to come this side. So it means Y is going to be brighter than X, because X has is only experiencing or is getting less current according to the division of current there. So They are saying comparison of the brightness of X and Y in parallel connection. So in parallel connection, I'm expecting X to be dimmer than Y, because according to the division, according to the division of electricity there, when current comes there and then divides, because this one current will always go to a path where there is a lesser resistance. So Y has a lesser resistance compared to X. So less current will be going there, more current will be going to Y. So that is why X must be dimmer than this. So let's entertain it again. Let's go to that. So it means we are looking only at number A and number C. Number A says on the right hand side, X is brighter than Y, which is not possible because X has high resistance. Because of X in the question, the bulb X glows brighter than bulb Y. So the impression is bulb X has higher resistance. So X is brighter than Y, it won't work in this case. But number C, because the first part we talked about the brightness in parallel, and then number 2, this on the right hand side we are saying X is dimmer than Y. It's as good as saying Y is brighter than X. So it means number C should be the correct answer in this case. So I hope this should be the last one. The last one here before we take the break, a battery in the circuit diagram below has an EMF of 12 and a negligible resistance, 2 voltmeter V1, V1 there. So the V1, it is across a switch there, and then V2 are connected as shown. So V2 across the resistor there. The reading on V1 and V2 when the switch is open. So when the switch is open, what is happening in this circuit? It means there is no current that is flowing. So for us to have a reading of V2, let's start with V2. For us to have the reading on V2, current must flow past the resistor so that we use the equation V is equals to IR there. So when we don't have I, there is no way we are able to have a reading there. So V2 is equals to 0. So I eliminate. I come to here where it talks about V2 as 12. I eliminate A and B because they say V2 is 12. And there's no way V2 can be 12 as long as the switch is open. Even when the switch is closed, I don't think it can be 12 because we'll be having a voltmeter there and voltmeter there. So 12 is just a number that is not possible with V2. So it means V2, it is 0 in this case because there is no current that is flowing since the switch is open. So we are going to entertain C and D. We eliminate A and B. So let's go to V1 and check what will be the value of V1. So we can take, you must remember, if we connect a voltmeter will be there. The voltmeter will be there. I'm sorry, the answer came out, but let me just explain. The voltmeter will be there. But the reading on the voltmeter there will be 12. But when we take this circuit like this, and then we go around this, it is as good as connecting this V around there. Because it will be just, let me rather draw it so that you are able to see it. I'll just show you now what I mean. So look at this circuit. We are having the battery there, and then the wires, and then V1. And then we are having that. So what is this voltmeter reading will have the same reading as that voltmeter. Because all of them, they are parallel, they are connected parallel to to the source of electricity, which is the battery in this case. So this case is similar to this situation there. When the switch is open, we are going to take our wire going like that and going around, going towards V and pass this side and continue whatever way there and then up to there. So it means if the reading here is 12, the reading for V1 must also be 12. So that is why the answer is C. And then from there, we are going to take a break. And after the break, we can continue. We'll take some few minutes. And then after this, we'll continue. Thank you for participating in this. Thank you. Bye. Welcome back for the second session of this presentation. I think we spend a lot of time looking into the paper one. Let's entertain for 40 minutes or so the paper two in this time around. We'll go straight to a presentation. It says, number one, the first slide. Consider the reaction between zinc granules and hydrochloric acid. You must remember zinc, when it reacts with hydrochloric acid, would always produce hydrogen gas. So it says, how can the rate of production of hydrogen gas be increased? So the first one, it says use zinc powder instead of granules, increase the pressure, add water. How do you expect more product if you still add water in the mixture? And number D, increase the volume of the container. So in this case, I think the answer is quite clear and simple. For us to increase the rate at which we get hydrogen gas, we can only change the state of the zinc and use the powder. If we use the powder, the reaction is going to be faster. I think that is a little bit clear. Number two, consider the balance equation for the reaction at equilibrium. Below, calcium carbonate reacts to form CaO plus carbon dioxide. The Kc expression for the above reaction, you must remember the Kc expression says the concentration or the product of concentration of the products divided by the product of concentration of the reactants, where that is applicable. So in this case, the state of matter also is very important. We know the solid will never be part of the Kc equation. So it means we are going to cancel out where we see CaO and CaCO3. So we will be left with this. The question, it means I can eliminate A and B, and I will be left with C and D. But which one is the most correct between C and D? In this case, we have 1 over carbon dioxide, but we know the Kc expression, it says the product must be the numerator. So in this case, we are going to cancel the reciprocal of this cannot be correct. So Kc for number D is incorrect, but we can accept Kc for number C because we cancel all the solids, so we'll be left with the product, which is the concentration of carbon dioxide in this case. And then pure hydrogen iodide decomposes in a sealed container according to the following balance equation. And then we should know at this case, the dotted line here, it means our reactants. So the reactants is going to decompose until products are formed until such time the rate at which the reactants decomposes is equals to the rate at which the products are produced. We reach the equilibrium there. The reaction reaches equilibrium after 6 minutes. So after 6 minutes, it is somewhere there. When it touches, the rate is the same. And suddenly change in conditions at time 10 minutes. So time 10 minutes, I'll take it is there because I see a change there. The rate of let me start here. A sudden change in conditions at time t minutes causes the rate of both forward and reverse reaction to increase as shown in the graph below. So there is a change that affects them to increase both the solid and the dotted line. Which one of the following adjustment was made after 10 minutes? The adjustment that was made after that caused that change. So the first one, it says the catalyst was introduced. We can look into that. The temperature was increased. So according to delta H, the temperature will favor the reaction that needs temperature. So delta H is greater than 0 there. You know what does that mean. Number C, the volume of the container was increased. I don't think that may be the problem. But let's look closely what happened. Suddenly the line of the dotted line goes up. That is the disturbance. And then the solid lines follow suit. So the solid line means the Cauchy's principle cancel the effect. The equilibrium system cancel the effect. But what is the effect? The effect is the line going upward. It means the reactants somehow they got increased, and then the Cauchy's principle cancels by also increasing the product. So the most correct answer, it can be the amount of HI was increased at this point. HI was increased because the dotted line goes up first, and then it was followed suit by the solid line. So the correct answer, it is D in this case. So when reversible chemical reaction is in equilibrium, so we know when we talk about reversible reaction at equilibrium, what is important about equilibrium, we are talking about the rate of the forward and the rate of the reverse reaction. So once the statement, they don't talk about the rate, it means they cannot relate with what the question is all about. When a reversible chemical reaction is in equilibrium, what is happening? The concentration of the product and the reactants are equal. So they may be equal, but we are not talking about the rate. Number B, the forward and the reverse reaction are equal. What is important at the equilibrium, we are talking about the rate. Number C, the forward and the reverse reaction occurs at the same time, at the same rate, in fact. That is closer to what we want, because it talks about the same rate. The Cauchy's principles may no longer be applied. I think that is the Cauchy's principle is applied especially at equilibrium. So the correct answer, it looks like number C, that says the forward and the reverse reaction occur at the same rate. So C is the correct answer for this one. So this one, consider the reaction represented by the balanced equation that x2y2 is equals to 2xy. The activation energy of the forward reaction is 100 kilojoules, and that the reverse reaction is 130. You must remember the heat of the reaction is the amount of heat that must be added or removed during the chemical reaction in order to keep all the substance present in the same temperature. So the heat of reaction determines the constant pressure, is also designated the enthalpy. So in this case, the simplest way to do this, we can look at the rate, the forward reaction 100 joules, and then the reverse reaction is 130. We can find the difference of the two by subtracting 130 on 100. And if we do that, the heat of the reaction for this reaction can be only number D, because of the joules, the kilojoules that are provided in this question. And then this one, earlier I said to you, sometimes when you go through this kind of questions or questions of multiple choice, don't get too excited, because if you get too excited, you may be confused, or you may get the wrong answer easily. Gas X. Gas X is placed in a flask, which is then sealed. So gas X decomposes to produce gas Y and gas Z. So let's check what they are saying. and the number of moles of X is 3 at the beginning of the reaction, and it decomposes. And after a while the products are formed. So the product are formed to Y and Z. So the reaction reaches dynamic equilibrium after a certain period of time, as shown in the graph. So after some time, we reach an equilibrium. We reach equilibriums, let's say close somewhere there. There is an equilibrium there. So if you want to the interest of what is happening at equilibrium, how many moles do we have? We have, let me start with X. This is our X. At equilibrium, we have 2 moles of X, according to this graph, at equilibrium. And then we've got, at equilibrium, 3 moles of Z. And then at equilibrium, we've got also 1 mole of Y. But listen to the question clearly. The question says, which one? It does not talk about what is happening at equilibrium. It says which one of the following balanced chemical equation represent the decomposition of gas X as shown in the above graph. So let's interpret this. Which one of the following balanced chemical equation represent the decomposition of gas X as shown in the above graph? So it means I said at equilibrium for X we are having 2 moles. Out of 3 moles, how many moles were decomposed? If at equilibrium we are left with 2 moles, it means 1 mole of X were decomposed. So we want the state according to the decomposition of X, not according to the state of equilibrium. So the state of equilibrium says there are so number of moles, there are 2 moles of X. But the question, it talks about the number of moles of X that were decomposed, which means for us to be left with 2 moles at equilibrium, only 1 mole out of 3 was used. So we want the equation according to number of moles that was used of the number of moles of X that changed to form the product. So only 1 mole out of 3 was changed. It means which one of the following balanced chemical equation represent the decomposition of gas X as shown in the above. So I want to eliminate here between A, B, C, and D. I'm going to eliminate B and C. Why am I eliminating B and C? Because the expression of B and C, they talks about X at equilibrium, not X decomposed. They don't talk about decomposition of X. So how many moles were decomposed out of 3? Only 1. So I can entertain X as a 1 between A, N, and D. A and D, they can give me the answer. So let's check at A. A, it says there is Y, X, and then 1 mole of Y, which is correct, 1 mole of Y there, but it says there is 2 moles of X, of Z. No, there's no 2 mole of Z. So let's look at D. D, it says 1 mole of X, so X left, it is 1 mole. X left is 2, ne? But X used to form the product, it is only 1 mole out of 3. And then what is formed out of that 1 mole? Y is formed. 1 Y is formed, which is that, and then 3 Z is formed, which is that. So we've got so many number of moles, which is 3 moles of Z. So according to decomposition, we've got 3 moles of Z, we've got 1 mole of Y, and we've got also 3 minus 2 moles of X, which is X and then Y and then. So number D is the most correct one. I hope in most cases, if you can look at the first glance, you'll think that the question is looking for number of moles at equilibrium, because normally when we calculate Kc, we entertain number of moles at equilibrium, but this has nothing to do with equilibrium. It deals with the decomposition. How many moles of X were used up to produce 3Z and YY. So write the equation according to that. So that is what was needed there. I hope I explained it well. So the other one, the boiling point of a compound is, so that is where we are talking about the definition. If you understand the definition, and then you can't go wrong. The boiling point of compound is, number one, a minimum temperature at which it boils. Number two is a maximum temperature at which it boils. We can scratch out the two. And then number C, the average temperature at which it boils across the possible atmospheric pressure. And number D, the temperature at which the vapor pressure equals to atmospheric pressure. So we can entertain C and D in this case and eliminate A and B. So the most common, the one that makes sense to me, it is number D, the temperature at which is vapor pressure equals to atmospheric pressure. So that is why I'm saying it's only a definition. If you know your definition of the boiling point, there's no way you can get this one wrong. And then all members of homologous series differs only with, so this is a type of a recall. These are the questions that we must definitely take advantage and capitalize on such questions. So this one, it is a known CH2 is the difference in the homologous series. And then the next question, a group of atoms that determines the physical and chemical properties of ketones. So we have to entertain the carbonyl group for the ketones in this case. You have to know the formation of the ketones, what is important about the ketones. So the answer will be the carbonyl group. The destructors, obviously, they should be there, but if you know anything about the ketones, you should be knowing the information around the carbonyl group in the ketones. So consider the compound with a molecular CH4, H10. I think these are the principles that normally teachers, they are covering well when they start to introduce the naming of structures, the isomers, and something like that. Normally, this one is the first one that normally comes to the to teachers' exposure, that is exposed to teachers, and then they are normally, a lot of books I always get this one. How many structural isomers does this compound have? So this one you can just take it in and put it and shelve it nicely in your mind. Once you get this, you've got, the 2 marks is given. So the answer will be 2. So the structural isomers for CH4, H10 is only 2 structures that you can get out of there. And then consider the compound below. The correct IUPAC name for this. So what is important here is your numbering has to be very, very spot on here, because you must number such that the side from which you start your numbering must be closer to the end or any attachment, any branch. So according to this, I think the correct way to number this The longest chain, it will have 1, 2, 3, 4, 5, which is a pentane, five carbons. And we have a branch there of methyl, and then a Cl there. So the numbering should start from this end, which is 1, 2, 3, 4, and 5. And then at carbon number C, alphabetically, the Cl comes before the methyl. So it will be, at carbon number 3, we are having the chloro, and at carbon number 2, because we started numbering from this side, carbon number 2, we are having a methyl. So it means it should be 3 chloro and 2 methyl, and then the longest chain, which is pentane. The correct IUPAC name for this, let's look at that. So A should be the correct IUPAC name for that structure. The next part, 2 organic molecules, organic substance reacts to form water and the product with the following structure. So this is taken from esterification. So looking at this closely, we can realize that before we even do that, what are the names of this product? The product and one of the reactants to prepare this product. So the name of the product and one of the reactants to prepare this. So we know, by looking at the structure, we can see that the reaction there, it is between an alcohol and carboxylic acid. So the part of the alcohol, which is this part, it has only 1 carbon and 3 hydrogen. It means it was taken from methanol. So the methanol was reacting with a carboxylic acid with 2 carbons. So that will be the ethanoic acid. So this was the reaction between methanol and ethanoic acid. So they form this, which is methyl ethanoid. The name of this structure will be methyl ethanoid. So what are the names of this product? So I said already, it is methyl ethanoid, this structure. So what are the names of this product and one of the reactants to prepare this product? So looking at this, we've got methanol and ethanoic acid, number A, number B, methyl ethanoid, and ethanol. And number 3, methyl ethanoid and methanoic acid. And number 4, ethyl methanoid. Let me check something. The answer here, it is methyl ethanoid, like I mentioned earlier. So and the alcohol that is used here, it cannot be ethanol, because we said it is an alcohol with only carbon, which is methanol. So fortunately, if there was a methanol, if there was methyl methanoid and methanol, then we are going to for that option. But in this case, it is methyl methanoid, and then the last part, because we said the reaction is between methanol and ethanoic acid. That is why they took one of the reactants as ethanoic acid, because we said the reactants are methanol and ethanoic acid, and then the name of the structure, it is methyl ethanoid. So the C is the correct answer, because the name of the structure is methyl ethanoid, and one of the reactant is between methanol and ethanoic acid, so they took ethanol acid. So the only close one could be this one, methyl ethanoid, but the wrong alcohol was used there, because this is an alcohol with 2 carbons. So here's an acid with 2 carbons instead. So that is about that one. So looking into this one, consider the reaction represented below. We've got the longest chain there. Be mindful, I forgot to just subscript this ones here. We've got the longest chain there, but it's broken down to form the smallest chain and hydrogen and product X as Z. So, which one of the following correctly gives the type of the reaction that takes place and the IUPAC name for the product Z? So, for the structure to be broken down to the smaller structure, that part only, it says to me there's no way we can talk about addition. For a structure to be broken down, it is elimination. So elimination, it means A and B. We are going to entertain A and B. And then we are going to eliminate C and D. So eliminate, this time I'm talking about the answers. We cut off C and D. We are left with A and B. Which one of the following correctly gives the type of the reaction? So the reaction, it is elimination. And then which one of the following correctly gives the type of the reaction that takes place and the IUPAC name for the product Z? So product Z, so when we eliminate, at one point you must create a double bond. So the propene, between propane and propene, propene has the double bond. So this, between A and B, they were very, very close, but elimination always creates a double bond. We can take it like that, and then the answer should be A. And then, which one of the following statements about weak acid is true? So let's read through all these answers. Like I said in the beginning of the presentation, it is a proton acceptor. So acid is not a proton acceptor. Acid is a proton donor. So A is wrong. It can have a high concentration. We'll look into that. And number C, it neutralizes a strong acid. So the acids are neutralized by bases. There's no reaction where an acid neutralizes another acid, because we are talking about the weak acid here. So C is impossible. Number D, it reacts with sodium carbonate to release oxygen. So it looks like the property of a strong acid, that one. So the only answer that is left, it can have a high concentration. So it can have a high concentration, that is a possibility. So to me, it looks like the correct answer is number B. And then an amphotic substance can act as either acid or base. Number B, donates or accepts electrons. You must remember, when you talk about amphotic, we are talking about acids. Donate and accept electrons. When you talk about acids and base, what is important more is hydrogen, which is the positive the protons, not necessarily the electrons. Act as an acid only. No, there's a reason why it is amphiphoric and acts as a base only. So C and D, they are out. We are eliminating them. So donate or accept electrons. Electrons is the wrong word. If they were talking about protons, then we'll look into it. So the correct answer remains 1 there as the number A. And then that brings us to the end of the presentation, but we want to highlight some few things. It is very important to pack up your questions and its multiple choice together closely. When you are answering the question on momentum, or let's say you're answering the question, the structured question on Newton laws, always try to answer that coupled together with the multiple choice question. In that way, you are working in small packets and you'll be able to make effect. So one other thing that we want to encourage the teachers to do, it is to make sure that you give the learners activities, daily activities on multiple choice. Please take it seriously. Once the teacher take it seriously, the learners will also take it seriously as well. So thank you for your time, and let's make that 20% or 20 marks, which is about 13%, count